Okay, science. Um, Hi everyone, I'm Jingjing from the University of Sydney. I present the NTIRE challenge on perceptual image quality assessment. This challenge is organized by me, Hao Ming, Chao Dong, Jimmy Ren, Yu Qiao, Shu Hang, and Radu. Firstly, let's have an overview of this challenge. In recent years, research on image restoration and enhancement begins to focus on obtaining better perception effects rather than just higher PSNR values. In 2017, SR was proposed to introduce perceptual losses to super resolution. In 2018, PIRM challenge was held, which employs the perceptual index as a metric. This year, image quality assessment as an extremely important task in perceptual image processing is the first time as a challenge topic to appear at one of the 12 conferences. It is where we are now. Okay. What is a perceptual image quality assessment? As we know, image restoration and enhancement are classic computer vision problems. In recent years, many algorithms have been proposed to improve the perceptual performance of the output images. How to evaluate the similarity between different images and ground truth is a key factor for the fast development of image restoration algorithms. The core technique behind this evaluation mechanism is the image quality assessment, the IQA for the short. However, it has been noticed that the contradiction between the quantitative evaluation results and the real perceptual quality is increasing. For example, the sobriety of PSNR and SSM values does not always in accord with better visual quality for perceptual-oriented algorithms. This is already pointed out in the PIRM challenge, and even the perceptual index, the metric used in the PIRM challenge, fails to indicate the perceptually better image. An important reason for this situation is the invention of GAN-based and perceptual-oriented image restoration method. They bring completely new characteristics to the processed images. These perceptual distortions are completely different from the traditional distortions appeared in previous IQA research, such as noise, blur, and compression. New IQA methods need to be proposed accordingly to adapt new image processing algorithms. The NTIRE 2021 challenge takes a step forward in benchmarking perceptual IQA. The task of predicting the perceptual quality of an image obtained by perceptual-oriented algorithms. Our goal is to pushing developing state-of-the-art perceptual IQA algorithms to deal with the novel perceptual distortion types. To hold this challenge, we employ a novel dataset called PayPal as the training set and collect an extended subset of PayPal as the validation and testing set. The arrangement of the dataset is listed as this slide. The training set contains 116 different distortions and 23,000 images in total. The training set contains both traditional and perceptual distortions. The validation and testing set contains only perceptual distortions. More detail about the PayPal dataset. The PayPal dataset includes 250 diverse reference images, and 200 of them are used in the training set, and 116 distortion types, in total to 29,000 images. PayPal is rated using the ELO rating system, and more than 1 million human judgments are involved in PayPal dataset. The scale of the PayPal dataset is larger than the existing IQA datasets. We also collect a PayPal extension set for the challenge, which includes 15 reference images from the original PayPal dataset and 66 distortion types often are perceptual distortions. In total, 3,300 images. We also employ algorithms to assign the subjective scores, and this is based on the original paper ratings. More than 75,000 additional ratings are included. The evaluation method of this challenge is based on two metrics, the Spearman rank order correlation index and the Pearson linear correlation index. The Pearson index is calculated after the third order polynomial fitting. The timeline of the challenge is listed as in this slide. The challenge started at January 10th and ended at March 20th. During the developing phase, we have online validation server for the participants to validate their method. The final submission for the participants include code, fact sheet, and test results. Next, we conclude the challenge results. We have in total 217 registered participants. 78 of them submitted to the validation server, and 22 of them participated in the testing phase, and 13 participating teams submitted their final solutions and fact sheet. This table lists the main results and some baselines. On the left, we also present a convenient visualization of this method's performances. As can be seen, 11 of 13 teams surpasses the highest performance of the existing algorithms. The champion team refreshed the state-of-the-art performance on paper dataset. Recall that an important goal of this challenge is to provide more promising IQA metrics for perceptual-oriented image processing algorithms. We show the scatter plot of using these metrics to evaluate perceptual algorithms. As can be seen, the top solutions perform well in evaluating the images in the testing set. Among them, the correlation between the evaluation of the champion solution and the subjective score reaches 0.95. We also show the performance of the challenge methods on TID and live dataset. Although the challenge method cannot beat carrying the state-of-the-art IQA metrics on these two traditional datasets, they show a competitive performance. We then briefly review the top challenge method. The champion team comes from LG. They applies a popular transformer architecture to the perceptual IQA test, which has gave the presentation before. The MTGTD team from Meituan wins the second place in this challenge. They contribute a new bilateral branch multi-scale image quality estimation network. And this team will have their presentation later to introduce their method. Two teams from Tsinghua University wins the third and the fourth place in this challenge. The third place team extend the LPIPS metrics and propose learning to learn a perceptual image patch similarity method. And the fourth place team proposed a region adaptive deformable network. The proposed method is trained from scratch, and no pre-trained model is used in their method, which is unique among all these challenge methods. At last, we outlook some possible future challenges and works. Firstly, in this challenge, we did not distinguish between the method of full reference and no reference IQA method. As full reference method tend to have better results, it squeezed the room of no reference IQA method. However, the later one is quite important, so we try to include different tracks for different types of methods to study their comments and differences. Secondly, we only include perceptual distortions this year. As shown before, some methods perform good for perceptual distortions but cannot generalize to traditional distortions. If we include traditional distortions in the testing phase, the results may change. And then we actually should rethink the meaning of IQA toward image restoration and the evaluation of IQA method itself. In this year, we evaluated the IQA method according to the traditional evaluation method, but in the course of practice, we found many defects actually. For the future works, how should we evaluate IQA methods is still worth in research. Let me conclude the presentation by giving thanks to our sponsors. They make this challenge possible, and we especially thank SenseTime for their help in collecting annotations for the distorted image. Please visit our website for more information. Thanks for your listening.